what I usually do, like I'm doing right now, I just hit the record button, so you're going to hear this. Like if you go back and watch the YouTube video, and it goes slide. There's not too many. So let's talk about the basics of geometry. Geometry has to do a lot with shapes and special principles that we know about shapes. If you are interested in any type of engineering, it has a lot to do with shapes, straight lines and like what they do and certain angles. I like to work with tools a lot. I like to build. Like at home, I like to build things. If you go on any of the retreats and they do like sets, or if you're into even like acting, like the sets that are built use all the principles of geometry to do them. So the very basic unit that we use in geometry is called a point. It is a single dot. So it is just one single dot. I'm going to blow it up a little bigger there because I can make that bigger on my screen. So a point is just a single dot, and it's the simplest figure. And when I say a single dot, it's like a dot. And I can't even make it small enough, because if you said how wide is it, it doesn't even have anything that we can measure. It's so teeny tiny, it's the smallest unit that we can make. And we use capital letters. This is so important here. We name them only with capital letters, never a lowercase letter. Be careful with this, because I will try to trick you with that. I will do something like this. I will be like, what is the name of that point? And you might be like, oh, that's point A. And I'd be like, nope, wrong. That is not anything at all. We cannot use lowercase letters. We only use capital letters. Every geometric figure consists of points, just tons of them, like tons of little points. In Algebra 1, you guys actually use things. You graphed points, and then you connected them using lines. So you used points, and if we put a whole bunch of points on there, we would see lines. So all geometric figures consist of points. Geometric figures are going to be all of those things that we can use a whole bunch of points and do a whole bunch of shapes. So then we go on to lines, and here are some very important things. If I'm stressing it, it's because I know where people mess up in here. So a line is a geometric figure, just like we expect. It's a straight line, and it has at least 2 points, and here's why. Let's say that I make a point right here, and I said, draw a line through there. You could draw this line, or 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 you could draw this line. There is an infinite amount of lines that would pass through that one single point. An infinite amount. I can make it go any direction. However, as soon as we use 2 points, we are forced into making one line. You and I, as much as we try, if we are talking about a straight line, would all draw the exact same line when we go through those 2 points. It would look something like that. We couldn't have it going any direction in the world we want. It has at least 2 points, and it extends in 2 directions, and it never ends. It goes infinitely on in one direction and infinitely on in the other. It never ends. Never, never, never. It keeps going and going and going and going. So when we draw a line like that, it means that it continues on forever. A number line technically goes on forever. It's got that arrow on the end, meaning the numbers go up to 10 billion and keeps going. When we name a line, we name it using 2 points. For example, we could write line AB. Notice that A and B are both points on this line right there. That's line AB. Sorry, that's really sloppy. Let me clean that up. So A and B are both lines. When we talk about lines, we don't use 3 letters, but you have to use at least 2. So line AB. We can't just use 1, because I don't know what we're talking about, what direction it goes if I only use 1. We're talking about the line that goes through A and B. Or we could use 1 letter if we are using, it'll have this little like cursive looking letter off to the side next to it. That is acceptable. If you see a little cursive letter off to the side at the end of one of the lines, it could be on the left or it could be on the right. It could be like a little cursive L. It might be a very fancy looking M. Now, those do not have to be uppercase. Those could be anything else. So it's a little confusing at first. Another way to write them is just like this. Notice it's line, we say line AB. The arrows on top show it goes infinitely on in every direction. So it's the line that has points A and B. It goes forever in one direction and forever in the other direction. I don't want to say left and right because it just means it goes on in 2 directions. It could be going diagonal, it could be going up and down. Or we could just call it line L because it's got that little cursive L on the side. Questions so far? Yes, sir.
So the cursive letter does not have to be uppercase, and that's the only exception?
Correct. You're going to write whatever cursive letter is off to the side. If they have a little lowercase e like that off to the side, then you could say that's line E. So it's just another way. In the homework, you're going to see that's one of the options. And one of the problems you'll be like, but wait, I don't see 2 letters on there. In the case where I'm going to use this letter, I don't use 2 points. I would use just that. But I could use, if I'm going to use points, those points are the dots, then I use 2 of them. Always use 2 points for a line. Now, as we go further in, you're going to see that other things use more than 2 points. But for this, just 2 points. Feel free to stop me. Do not listen. If you have a question, I would bet $50 that somebody else in here does too. Geometry is not like every other math. It's got lots of different definitions in there. So do not be afraid to throw yourself under the bus. Trust me, I will not call you out. I will not hurt your feelings. I just want to make sure we all got it. Yes, ma'am.
Sorry, I just missed the blank on the first slide. I
Okay.
missed the blank on
Yep.
the first slide.
Okay. So now we're going to move on to a plane, and a plane is a little bit difficult to understand, so I'm going to be very visual. I'm going to stand up when I do this. And so a geometric plane is suggested by a floor, wall, or a tabletop. So when we talk about the floor, think about the floor. It's a flat surface, right? It goes like in this direction, and it goes in that direction. In essence, it's a 2-dimensional figure, right? It's flat on the ground. It's like a giant rectangle almost. It goes in this direction, and it goes in that direction. The ceiling, also, I know, granted, it's technically 3-dimensional. We live in a 3-dimensional world, but we're just talking about the rectangle that goes there. This wall is like a rectangle. It's a plane. It goes from left to right. It goes up and down. The difference being when we talk about a geometric plane is they extend forever. Now, here's the thing. I can't really draw something that extends forever. Like, if you notice this plane down here, this plane has a shape, right? I mean, it's like, yeah, it stops right there. But the truth is a plane never stops. It keeps going on forever and ever and ever. To the left, this keeps going whoosh, to the left. It keeps going whoosh, to the right. It keeps going whoosh, up. It goes whoosh, down. The one dimensions that we're not representing, it's not coming at you. It's not the third dimension coming at you. And it's not going backwards because we can't see that, right? Like that's not being represented. We see that it goes to the right. We see that it goes to the left. We see it goes up, and then we see it goes down. It goes on forever. Now, we don't have anything like that in the real world because everything has dimensions. Like we can measure them, even if they're really huge. But imagine that the ceiling just shot off into infinity in that direction and in that direction. Like if we could extend it forever, that's what we're talking about with a plane. It's just a flat surface. A rectangle, it could be like triangular shape, but it's a flat surface. It extends without ending and has no thickness. So if I said a piece of paper, I mean, that's pretty close to a plane except for a couple things. Number one, a paper has thickness. It does. It's really thin, but it has a thickness. We don't care about how thick it is when we talk about planes. We're only talking about just like left, right, up, and down. We don't care about how thick it is, that third dimension. And a paper doesn't go on forever, but a geometric plane does. It goes on forever. Lines go on forever. Planes go on forever. And we can name them in a couple different ways. We can name them with a single capital letter. Notice there's a single capital letter right there. They have to provide it to you, though. Or 3 or more points it contains. Now notice I don't see any points in here, so I'm going to show you what that would look like. Let's say, imagine it's like a sandbox. And contained within that sandbox is point A. I drew A within there. And here is another one that is inside there. And maybe one right on the edge there. So it would be perfectly okay to call this plane A, B, C if A, B, and C are in that plane. That's one way of calling them. Like you go 3 points now. Now I can't use 2 because 2 points represents a line. So those 3 points there, notice one of the things that's so important is that there's a term that we're going to talk about. Those 3 points cannot be on the same line. And notice they're not. A and B are. And when I say line, and this is going to be something that's true all the time, when I say line in geometry, I always mean a straight line. Never like a curvy line, never a bent line, things like that. The word line means perfectly straight. It'll always be straight. Now, there are things that are bent and curved in the world, but we're not talking about those shapes when we talk about geometry. We're talking about those straight sides, like flat. So we can name it with a capital letter, like plane M, or 3 or more points it contains. So here are some terms that are going to come up. Space. When we talk about space, we're not talking about Star Trek, we're not talking about Star Wars, we're not talking about like outer space. We're talking about the space of a shape. Like in a triangle, like we might have a triangle, the space that is all of the points involved in there, all the points in that triangle. So the set of all points, it means all the points that make up that thing, whatever we're talking about, a rectangle, a triangle, a hexagon, whatever it is, it's all of the things that make it up. Now, the next one is collinear. So that word let's think about this. Like a co-pilot, what is a co-pilot's job? What do they do? Yeah, they help fly the plane, right? That's what they do. They are in the cockpit with the other pilot, and their job is together to fly the plane. They help the pilot. So if two things are collinear, it means they share the same line. 2 points could be on the same line. For example, I'm going to draw one here, A, B, and they are on the same line. But if you notice, if I put C out here, A and C are not collinear. They are not on the same line. They are non-collinear, not on the same line. A and B are, A and C are not. B and C are not. They are not on the same line. There is a line that is drawn, and the only two that are there are A and B. Now, there's coplanar. Now, again, planes go on forever, but when we draw them, we sometimes just draw them as a rectangle or some sort of four-sided figure. So imagine when we're talking coplanar, they're on the same plane. So think about like this as like a sandbox. They have to be inside the same sandbox together. A, B, and C are coplanar. They are in the same plane, whereas, let me add one that's not. That one's outside of it, right? It's outside of the plane. It doesn't fit in that box there. If I said A, C, and D, they are not coplanar. They are non-coplanar, not in the same plane. Imagine it's a box and they're not contained within that box together. The ones that are A, B, and C. A, C, and D? Nope. C, B, and D? Nope. D is the problem there. D isn't coplanar with any of those. It has to be in the box. Is that a question or a stretch? Yes, ma'am.
How can you have a point that's non-coplanar if the plane supposedly goes on forever?
Such a great question. That's a great question. So here's her question, right? If this goes on forever, wouldn't that box wrap around that one that's D there? I'm so glad you asked that. Because what if point D is actually below it? So imagine, just for the video's sake, because you guys, they won't be able to see this, like when you watch it, imagine that imagine that I set like 3 marbles on top of this paper. They're all sitting in the same plane. I'm going to set this on your desk for just a moment. But then I hold another marble down here. This could go forever left and right, forever back and forward, but this one will never be on there because imagine it's going to shoot towards you forever and ever, and it's going to shoot towards me and chop off my head forever, and it's going to shoot to the left and right, but no matter how far it goes, it's never going to make it down here. It's got no thickness. It's never going to go in that direction. So in the same plane, that's not our ball, it's another class. So when we talk about in the same plane, when we draw it, we use the box to show things that are in the same plane. So it's a great question because what she realized that you're saying they go on forever, and if that went on forever, it would catch letter D there. But really it could be in another, like, I don't want to call it another dimension like Twilight Zone, but another like below it, you know? So it's off to that, it'll never reach it if we expand it. So that word co means they're on the same thing. Collinear, on the same line. Coplanar, on the same plane. Non-coplanar means they're not on the same plane. Non-collinear means not on the same line. So there's a lot of terminology that gets involved here. So an intersection. When you're driving, you come across a lot of intersections. You've got Flamingo and Griffin. That's an intersection because 2 lines are meeting. Intersection means to meet or to cut through. When one thing passes through another thing, like if I jammed a pencil through a piece of paper, that pencil has intersected that paper. Or when 2 lines cross each other, that is an intersection. And when 2 lines intersect each other, like this picture, if you notice, so only focus on those black lines for a minute, where is the point where those 2 lines cross each other? P, at point P. So 2 lines cross each other just at that one little point there at point P. So we've got an intersection of 2 figures is the set of figures that are in both figures. So like if I say where's the intersection of those 2 lines, what you guys did is you looked at those 2 lines and said where there's a point that is on one line and it's on the other line, that's where they cross each other, that is their intersection. It's the one that's on both of them. Now notice here it says dashes in diagrams indicate the parts hidden from view, meaning that that dashed line there means that line keeps going. For example, I'm going to do, like you'll see me, like in geometry, I'm all about like showing things in the real world. This paper, I'm going to jam my stylus right through it. It intersects it. Now I can turn this paper so you cannot see part of my stylus. Some of you might be able to, some of you may not see. But I hope you realize that I'm not a magician who made my pencil disappear on the other side. It's still there. You just may not be able to see it at that angle, and we represent that with the dashed lines, just to show that it's still going, you just can't see it from the angle you're at, because something is blocking it. So that's what we're looking at there, is that dashed line means that that line keeps going, it's just going like downward. So this is this line there, that line N, notice I called it by the little letter right there. Line N, the one that's going up and down, comes down, 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 and then it's still going down here. You just can't see it because it's blocked by that plane. You just can't see it. But then you see it again once it goes out of the range of the plane that you go, okay, I can see it after we get outside of that box. So that's what we're talking about there. Plane can be called that one letter that was in the corner. Remember we saw that one letter that was in the corner? You can call it by that one letter there. All right. Yes, sir?
Can a plane also be called by one letter if it's cursive?
Yeah, so a segment is just like a line, except for there's one difference. It does not go on forever. I don't know where you live, and you don't know where I live. However, I know that it is a set distance away. Like your house and my house aren't changing their distances. Here's your house, here's my house. They're a set distance away, and they are not going on forever. That is a line segment. It has a beginning and an end. It does not keep going. That is a segment. It's just a piece. It could be a piece of a line. Now notice here, I'm going to do something weird. I'm going to turn it into a line. So that's a line AB, but just this little portion right there, from my house to your house, is called a segment. It's just a piece of it. If I said, hey, can I get a segment of that pizza, it just means give me a little piece of it. I just want a piece of it. I don't want the whole thing, just give me a little piece of it. And so that is a piece of the line. So what we've got there is a line going on forever, but from A to B, we just have a segment. And it's just a little piece. We can measure those because they don't go on forever. It's written just like a line, except for it doesn't have arrows on them. So notice here, we've got line segment AB. It does not go forever, no arrows on there. It consists of 2 points, A and B. That means A and B are on that line segment. And we can also reverse it. We could call it the other way. We could call it BA. Because really, if I say how far is it from my house to your house, it doesn't mean start at my house and go to your house, or start at your house and go to my house. It's just the distance in between them. There's no start and no end. It just means that there's 2 endpoints from here to there. A and B we call the endpoints. So like it ends here when we're just talking about the segment, just the segment, it ends there. Now the line, it keeps going. There's parts of it that go on. But so for the purposes of talking about it, we've got a segment, AB, and it ends at A and it ends at B. But you can see it drawn both ways. Like you could see it stuck in the middle of a line. Like on a number line, for example, like you guys have dealt with this before. 1, 2, -1, -2. Even if these go on forever, I know how far it is from -2 to 2. That's a line segment. It's just a piece of this never-ending line. It's 2 units to the left, 2 units to the right. That line is 4 units long. So I can measure that. It's a line segment. But the whole number line goes on forever. Okay, so one thing I know about you, and I'm going to take a guess here, and every once in a while somebody calls me out and says, I didn't do it that way. When you were in kindergarten and you had to draw a picture, you probably drew a picture that looked something like this. I am no mind reader. I just know a lot about kindergarten students. You probably drew something that looked like this. There's like, for some reason, we all live on a hill. We're all stick figures. I don't know who are members of your family, so I'm not trying to represent. I'm just guessing all your family members were all standing outside of this hilly house at some time. And there was always something up in the corner. The sun. And so everybody kind of drew the sun up in the corner because, man, was it easy to draw the sun like that. That's the corner of my paper. And if you were really fancy, your sun looked maybe something like this.
Yeah. Oh, yeah.
Dang, were you a slick artist then? Man, you were like...
What I did, I put little triangles going all
Oh, all triangles going down? I like that even better. So I think she's saying it went like this.
Yeah.
Woo!
Or no.
So anyway, you drew yours. Now, here's why I bring this up. This is kind of a dorky thing that I talk about, but it makes perfect sense because almost everybody did it. Why did I draw those lines on the sun? What was my purpose of that?
To show the light was going that way.
So what do we call those lines, like when in kindergarten, what do we call those things?
Rays.
They are the rays of the sun. Now, here's what the rays of the sun do. Are those arrows supposed to illustrate that the light is coming from the earth and going to the sun?
No.
No, what do they illustrate to me?
That the light is coming from the earth.
It starts at the sun and goes outward from there. So it has a point that it starts and then goes out forever from there. And that's what a ray is, just like a ray from the sun. Ray AB, when we write it as AB, means it starts at A and continues on unending in the direction of B. So it starts right here and goes on forever in the other direction. But wait a minute, why does this say A is the end point if you told me it started at A? That makes no sense.
Because it can go like both ways.
Well, it only goes one direction. It starts as the sun and goes outwards. But why would I call A the end point?
Because that's like where it starts. So like you can't go.
Yeah,
Like,
that's the only place where it stops. There's a stopping point right there, right? You can't go any further in that direction. That's as far as it's like the other direction. You don't call B the end point because it doesn't stop in that direction. It keeps going and going and going. The sun's light, whether you like it or not, going through space goes on forever and ever and ever. And it dissipates. And maybe it's not as bright at some point, but it keeps going forever and ever. So we call this point where it starts, this first letter in a ray, is called the end point, even though it's where it started. It's a weird name, but that's where it started. So when you draw this, like if I said to draw, let me just come up with a new one. Let's say I said draw ray CD. What I better see from you is I don't care which direction it goes in, but I do expect this. You start at C. Now I don't care which direction you go. You can go northwest, you can go north, you can go southeast. Those are 2 points on this ray, and the end point is at C.
Wait, but I thought for D you don't draw a point.
So there's definitely a point there, and if it's not shown in this line, there should be. So I don't know whether there's an actual, let me clear this off so I can see what your notes look like. So there should be a dot on both of them. So it's 2 points. Now it doesn't end there. It just means like the reason I need that second point is because I don't know which direction. I can start at C, but then where do I go to? Give me an idea, like go from C to where. That's what the second point tells me to do. Otherwise, I could have gone anywhere. I could have gone here, I could have gone here, I could have gone here. But really, D tells me, nope, go straight through D and continue on forever, just like a ray from the
Then how do
sun.
you know that's not a line?
Or a segment.
So, great. How do I know that? I could say that there is a segment from C to D. That CD, like just this portion right here, just that portion is a segment. That would be correct. That's a segment.
Yeah.
But the whole thing, that whole thing that I drew there, the thing that looked like this, the whole thing is called a ray. The whole thing. Why is it not a line?
Oh wait, because there's no arrow.
There's no arrow on the other side. It's missing an arrow on the other side. And that's the difference between a line will go on forever. A ray goes on forever in one direction. But somebody, like you made a great point when you said, how do I know there's not a line segment? There is a line segment in there. You could call it line segment CD or line segment DC. So there's kind of like things within things here, and it's all kind of very interesting. You're like, well, what's that? Well, there can be a lot of things in there. So when I don't know why I'm all crooked here. Let me fix that. Okay, so ray BA, if I just look at just that, here's the things that I know. Ray BA, this is the end point. That's the part that has the dot. And it goes towards A, so I'm going to shoot it off. Now, I don't care which direction you draw it. Draw it in whatever direction you want. Usually people just draw it off to the right because it's easier. We don't need to get too creative. BA like that is written BA. It starts at point B and continues in the direction of A. Notice that B is called the end point because it doesn't go any further at that point. That's like with the sun. It doesn't go shooting through the sun back in the other direction. That's its point of origin, where it ends. There's no continuing on in that direction. So think of the ray as like rays of the sun. That's what I always say. All right. Opposite rays are lines. That's what they are. So if I take imagine two people dueling in like the cartoons, right? They stand back to back and they continue walking in one direction. They stop at a certain point and they turn around and fire at each other in the cartoons and then whatever happens. So notice that opposite rays share an endpoint. So look, for a moment, let's not get too math nerdy here. Here is a ray, BC, and here is a ray, BA. Notice I named them from the endpoint there. They're opposite because they both share that letter B, and they're like back-to-back rays going in opposite directions. They don't bend, they're going the exact opposite direction. One's going up, the other goes down. One goes left, the other goes right. One's going diagonal to the down and left, one's going diagonal up and right. They always have to be going the opposite directions. They share an endpoint, that's this right there, and they point in opposite directions. Ray BA, that's the blue one, and ray BC are opposite ones. So there's my blue one, there's my red one. Like back to back, two rays shooting in opposite directions. Now if you're like, isn't that a line? Yeah, and you can call that line a lot of different things. You can call that line AB, you can call that line BC, you can call that line AC. You can choose any combination of two letters you want on there, and it's totally okay because it's not a ray. The only one where the letters matter for lines for all this first lesson are the rays. Whatever letter comes first is where that solid dot should be. It's going to look like that. And that solid dot is called the endpoint. I know it's a lot. There's a lot of vocabulary in this. But trust me, you'll be so sick of it, by the third quarter, you'll be like, I just want to go back to lesson 1. Okay, so let's play a little true-false here. Line PF ends at point P. Now notice I didn't draw anything here. Let's just talk about line PF. Think about what that would look like in your head. It ends at point P. True or false?
False.
Why false?
It's a line.
Lines never end. That's false because a line never ends.
We like right one.
What's that? For this is just, you want to make notes that help you. So what I do is I underline it's a line, it never ends, so that's got to be false. Point S is on an infinite number of lines. So there's point S. Can I draw an infinite number of lines through point S? Yes, because there's only one point. With one point, I could draw it up and down, I could draw it left and right, I could draw it diagonally, I could make them smaller and smaller, and I could go any direction I want. That is true. As long as there's only one point, then there is an infinite amount of lines. If there's 2 points, there's only one line I can draw. A plane has no thickness. True. We don't care about that thickness. We're not measuring that. Collinear points are coplanar. Now, so here's what we mean by that because we didn't talk about that. So imagine my Apple Pencil here has 3 collinear points, like 3 dots on here. I don't care where you put it, but one on one end, one on the other end, and one in the middle. When we say coplanar, it means that we can put them on the same plane, whether it be here, here, here. Is it possible that I can always put these on the same plane? So no matter which way I turn this, I can lay it directly on a plane. Is that true? Am I going to be able to turn this in a way that I can't lay a piece of paper directly on it?
Yes.
No.
So they are coplanar or they're not coplanar?
They are.
They are because there's no way I can put this, no matter just pick up and down. Well, then I can put the plane like this. Any 3 collinear points, any line will fit directly on a plane, no matter what, every single time. As long as they're on the same line, I can always fit them on there. If I turn it like this, bam, right there. Turn it diagonally, bam, right there. No matter what I do, try it every single direction, I'll be like, well, no matter where I hold this, I can lay it on a plane. So think of this as a plane. So as long as the points are collinear, they have to be on the same one. Because if I stick a point off, if I go, okay, these 3 points, and then a point down there. Oof, well, that's tough. Now this plane is going that way, but I need to pick up that one, and that's not on the same line? No. That I can't do. They have to be on the same line. If they're on the same line, no problem, I can do that all day long. All collinear points are on the same plane. That one is true. Planes have edges. Why false? I'm so glad you guys said false. Why? They go on forever. So even though it looks like it has edges, that's because we have to perceive it as human beings that it's like, how would you draw it? That it draw something that has no edges? I mean, you could just color like a single color, but it wouldn't show you like, where does this go? So planes have edges? That's false. So 2 planes intersect in a line segment. So think about this. I'm going to try to confuse you here. So think, I'm trying to trick you here. 2 planes. Here's one plane. Here's another plane. They intersect each other, and where they intersect, meaning the places that they touch each other, is a line segment. Meaning that where they touch each other is a line segment.
No.
Why no? Because it's infinite. So even though it looks like that's just a short line right there, you'd be like, yeah, that's like just a short line. That's got to be a line segment. Remember, this paper goes up forever, it goes down forever, and this one goes that direction forever, and this direction. So it's going to keep going and 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 going down here. So that line, I can't show you infinite amount of paper. I don't own infinite amount of paper. But if I did, I could show you that this keeps going up and up and up forever, and down and down and down forever. That line will continue forever. Because where planes intersect, since they go forever, is an infinite line. So some of this takes a little bit of thought, and you're like, oh my gosh, what would that look like in real life? So a line segment, that's false. Two planes intersecting, where'd I go? Two intersecting lines meet in exactly one point. Where those two planes touched each other, was that exactly one point? No, it was a line. Remember, we said it was a line. Two planes, that's like two pieces of paper touching each other, they meet together at a line. Oh no, I'm sorry, that says two intersecting lines. I apologize.
Yeah.
I'm so sorry. I'm having issues. This is why I teach math and not reading, because I can't read. That's why I married a girl who's an English professor, because I was like, she can do all the reading for me. So, two lines, let's talk about those. We saw two lines a moment ago that crossed each other, and where those two lines crossed each other, we had a what? A point. So when two lines cross each other, we definitely have a point. So two intersecting lines meet in exactly one point. That would be true. They can't cross each other again. I can't make these touch in two places unless I lay them right on each other, and then they're the exact same line. So they're not different lines at that point. I have to lay them right on top of each other, and then they become the same exact line. So at that point, the only way I can make them is just one point. I can't make it touch another time. Otherwise, I'd have to break one of them. Okay, points have no size. True, so even though you'd be like, yeah, but you drew it with some size, it's because how else could I show you that a teeny tiny dot that is infinitely small? So it is true that it has no size. Line XY can be denoted as this or this. Right, that's true. It can be written either way. Which one cannot be written either way? Array. Array's got to have a certain place that starts, like the sun. The rays do not go from the earth and hit the sun. It's vice versa. All right, so let's see. This is again some true or false. Let's take a look at this. Point P. So I'm going to find point P. That's this right here, I'm guessing. They didn't really put a dot there. We'll put it right there. Point P is in M, meaning that it's in plane M. Is that in plane M? No, it's not contained within there, so that's false. B, so that's a lowercase b there, so that represents that line. This line, because remember, we couldn't have used a lowercase for a point, is in M. Is that line in M?
Yes.
That's true. Line XY, here's line XY right here. Now they just show it as a line segment, but they must be talking about it going on forever. Line XY, wait, what did I say? Line YX contains point P. Is P on that line?
No.
Yes.
Well, so look, there's line XY. If this keeps going on forever and ever, is P on there? No, because it's a line, not a plane. Planes, remember, are like paper, and lines are like a pencil. Pencil is a thin line, so no, that P is not on that line. Most of these you could go like, well, is it on there? M, and when it says M there, I can see that M is this plane. It's that plane right there. It contains line YX. Is that true? Yeah, it's in there. It's definitely in there. It's this red one right there. It's contained in there. Now you may be like, but wait, isn't it going to go outside of there? Yeah, that line's going to go on forever, but so is that plane. It's going to go on forever too.
I'm confused why it's not in N2, because like wouldn't it be still in both?
Oh, you're saying that line? It is in both. Yeah. So it's in N and it is in M.
Then why is 3? Oh, never mind.
Yeah, because it was talking about point P on number 3. It was talking about that down there. Okay, so A, now it's a capital A, so it means point A. It's talking about this right here is on B. Is that on line B?
Yeah.
It sure is. That's true. I'm sorry, I didn't mark these. I should start marking these. That was true. M contains line YX. That was true. A and P are in plane M. So here's P, and A is... so why false? What makes it false?
P is not in
P is not in plane M, so that's false. N contains point P. So here's N. This is plane N. It contains point P. True, even if it's right on the border, it still contains it. It's still a part of it. It's part of that edge there. So yep, that's true as well. All right, so this is about sketching. This just shows you how to draw them, how you can draw a plane. It says to sketch a plane and a line that is in the plane. So here is a line in a plane. It's just showing you different examples of them. So I'm going to leave them up there so you can see them. The second one, B, shows a plane and a line that does not intersect the plane. So you can see on B that that line does not intersect the plane. If you're like, but wait, won't that plane cross it? Imagine that that is a pencil hovering above the paper. So you have to almost imagine it in 3D space there. And then for C, it says sketch a plane and a line that intersects the plane. And that's kind of like a pencil jab through the paper. Now, your drawings do not have to be perfect. I realize we're not all artists. I'm not even an amazing artist, and I do this all day with geometry. But I do ask that you, when it asks you to illustrate something, do your best to show me that principle. I'm not grading you on if this is an art class, but I do expect that you can kind of show me what that would look like. So I'm going to leave those up there for a second while you guys copy those down, and then we'll move on to the last slide. All right, last slide is what it looks like when two planes intersect each other. It says two planes that intersect in a line. What we mean is two planes crossing each other. When you think of planes, think of pieces of paper. Like if I could pass one piece of paper through the other. Now remember, like I'm gonna zoom in on this picture for a moment. Notice that where they cross each other, I've got little arrows. It doesn't show up too well, but I'm gonna emphasize them here. I've got arrows here, and I've got arrows here. It's to show that these planes go up. The green one goes up forever, it goes down forever. It goes left forever, it goes right forever. It continues on in all those directions. The blue one kind of comes at us forever, and it goes away from us forever, and it goes forever to the right and forever to the left. So where they intersect is a line, not a line segment, that's going to keep going forever. It's going to match the plane. If the plane goes on forever, then these two things are going to have that line that continues on forever. They're going to have an infinite amount of points where they touch each other because they keep going on infinitely. So hopefully you can see that right now geometry is like so much more different than other maths. You're like, I really don't remember like doing this much like vocabulary, and we haven't even really talked about any numbers yet. That's what makes geometry different. We are going to include numbers, and all that algebra is going to be built into these shapes here. So it gets to be a lot. Don't stress it. Like by the time the first week is over, you're going to have this like burned in your skull. That's most of it right there.